Welcome all to the second unit of the module Voltage and Current Sources. In Unit 1, we studied about application of Ohm's law, series and parallel networks. In Unit 2, we'll discuss about power, types of power, then types of sources, then KCL and KVL. Okay, the first topic, electric power. Usually students get confused between the word power and energy. What is power? Power is the energy transferred by an electric circuit in 1 second, or it is the rate at which the electrical energy is transferred. The unit of power is watt. There are many rules we can use in the calculation of power. The main rule is P is equal to V multiplied with I. This rule we use generally in the case of batteries, sources, where we know the information about the voltage and the current. In case of elements such as resistor, we can use the alternate expressions P is equal to I square R or P is equal to V square over R depending on the factors available. There are two types of powers, all depending on the direction of current. The two powers are power absorbed and power generated. Power absorbed, that is, if the current direction is into the positive marked terminal of the network, that is positive marked terminal of the network, then that power is called as absorbed power. Simply means that the power is absorbed by the element. Now, power generated means if the current arrow is directed out of the positive terminal, then it is called as power generated. The current is flowing outside the positive terminal, it is called as the power generated. So it all depends on the direction of the current, and especially remember that the reference is made at the positive terminal. If the information is not available at the positive terminal, we will have to extend it from the information provided at the negative terminal. Let's have some examples. In the first example, you are asked to calculate the power absorbed by the part of the network shown below. So since the voltage and the current information is available, we just need to look at what is the question and what is the actual situation. The question is calculate power absorbed. As per the definition of the power absorbed, the current should flow into the positive terminal. And if you look at the situation here, you can find that it is actually flowing inside the element. Hence, the equation is just the general equation. Power absorbed is equal to V multiplied I. That is 2 multiplied 3. The answer is 6 watts. In summary, if the question and the actual situation is the same, you don't have to do any modification in the equation. Equation is simply V multiplied I. The question was power absorbed and it was actually absorbing. That is why there is no change in the equation. Let's have a look at the second example. Here also the question is the same, calculate the power absorbed. But look at the situation here. First of all, there is no direction of current given at the positive terminal. But if you look at the negative terminal, you can find there is a direction of the current. But we cannot do the calculation with the direction of current at the negative terminal. We need to extend that information to be available at the positive terminal. So, if the current is flowing inside at the negative terminal, if you just extend it, you can find that the direction of current at the positive terminal is actually it is going outside. Now look, the question is calculate power absorbed. But what is the current? The current is actually going out. which is opposite to the definition of power absorbed. So whenever you find this situation, the question and the actual situation is opposite, you need to put a negative sign in the equation. So power absorbed in this example is minus V multiplied I, that is equal to minus 6 watts. So hope you understood the calculation. Let's see how much you got. So here is another example. Calculate the power absorbed by the element. So check, how do we start? Look at the positive terminal, no information. Look at the negative terminal, yes, there is an information about the current. Extend that. If the current is flowing outside, that means the current should originally start from here. So what is the current? Is it going out or going inside? The current is going inside the positive terminal. That means the element is actually absorbing a current. And that is a question. Calculate the power being absorbed. So since the situations are the same, the equation is simply V multiplied I, and you get 1012 milliwatts because the voltage is given in milli. Okay, let us see the same situation, but the question is different. Find the power generated by the same circuit element. See here, the question is power generated. What is the definition of power generated? Generate means the current is flowing outside the positive terminal. But what is the situation? Actually, the current is flowing inside the positive terminal. So whenever you find these opposite things, that means in the equation we have to put a negative sign. And hence the power generated is found as minus 1012 milliwatts. Or simply, for the same element, if you calculate the power absorbed and power generated, you can find this relationship. Power generated will be negative of the power absorbed. So now you know the calculation of power for single elements. In the coming topics, we'll discuss how do we calculate the power for the whole circuit.